All right, welcome everyone. My name is Amelie Obas.
Hello, everybody, and my name is Obas-Mensah.
Okay, in our research project, we're going to be talking about object-oriented database and PostgreSQL. I will start off with object-oriented database, and later Jordy will be talking about PostgreSQL. Are you tired of dealing with the complex data structures and relationship using traditional relational database? Have you ever heard of OODBMS, a database management system that stores data in the form of objects, just like the way we think about real-world objects? Well, I'm going to talk about how it can revolutionize the way we manage and access complex data. So we have to start off with objects in an object-oriented database. They both have data and behavior that are grouped in classes, into classes that determine the attributes and methods. Each object represents a unique instance of a class, and the relationship between objects are established through the respective class definitions. So OODBs, or object-oriented database, are useful for applications with complex data relationship and very large amounts of data. So we're going to start off with the research beginnings. The first commercial object-oriented database was called Object Store. It was released in 1986 by Object Design Incorporated, and it was widely adopted by companies in various industries. Such researchers that pioneered this was Michael Stonebraker, the creator of Postgres Object Relational Database System, and Gadia and Su, who proposed the object-oriented data model. Object Store allowed data to be represented as objects with attributes and behavior, and had features like object identity, encapsulation, inheritance, and polymorphism. They also have features that allow for creating, storing, and manipulating objects and in the database, and using core concepts that you would find in object-oriented programming. Today, there's active researchers that are contributing to the field, such as Stefano Seri, Richard Snodgrass, and Eliza Bertino. Object-oriented database offers more of an intuitive approach when it comes to handling data structures and relationships, simplifying the management and accessibility of data. However, it's challenging to implement because it requires a higher level of experience than your traditional relational database. There are several conferences. Go there. So there are leading conferences that are going on that are dedicated to this research. We have the International Conference of Object-Oriented Programming, Systems, Language, and Applications, which is shortened to OOPSLA. There's also the International Conference Database, Object Database, and there's two others, but I'm not going to read them all. You can see them on the slide, but these are the conferences that are going on. And the applications of the, sorry, I'm skipping something. The advantages of object-oriented database over relational database. There's 5 of them. There's data complexity, performance, flexibility, easier development, and grouping. And you can read the details to each of these advantages. And there's a side-by-side comparison of the object-oriented versus the relational. You can see that relational database uses tables, whereas object-oriented does not. And on the right side, you could see the tables populated, and the object-oriented data model also populated, and you can see how they are structured. And the applications that use object-oriented database are AutoCAD, or short CAD, electronic commerce, multimedia, scientific and engineering, banking, and finance, and business process management. They are best. You can use the object-oriented for them because they require higher performances, complex data management, and manipulation. So the object-oriented database is the best option to use. Okay. So this is just an illustrative example of an object-oriented database that I use with MongoDB. This is showing you me just enter in and then put in the information, start in a new database, and just populating it and coming up with a result that you would see in Mongo. I will show a version of it that I did just right now. Make sure I'm sharing the screen. Oops. Let's go back to sharing. First, let me show you the database. Get out of this. So as you can see, I have a collection that's called My Book Collection. The one that I showed you example is a book collection. And then I just created another collection called Book Users. And go back to visual. So as you can see, I've used the command insert many and then populated with different names with their ID, location, and the genre of book that they like. And you could show that it's been acknowledged. So the object ID was created. And then I added other commands where to count how many objects are in the collection. You can see it's 8. And also I added I also counted to see how many have the last name of Parrish, and there are 2 of them. As you can see, we have Remy Parrish and Theo Parrish. So that checks out. And I also inserted one more, Jody Mitchell, to the list, and it acknowledged it when it says true. So now when I do the count, there's 9. And of course, you can see a little errors that I made, but that happens when it comes to doing computer science. And I also try to find and sort by the last name. So as you can see, it populated the list based on the person's last name. So you can see Bird, last name, Jackson, Mitchell, Obas, and so forth. So this is just examples of how you can manipulate and enter data into the database. And I'm going to go back to the database just to show what happens in Mongo when you do this. So I'm under book users, and you can see that all the information that I entered into visual is shown up here, all the information. So even though object-oriented database can offer advantages over traditional relational database management system, it's important to know that they have their strengths and weaknesses, and the choice is based on the requirements of the project and how the data is being managed. So I'm going to pass it along to Jordy, who will talk about PostgreSQL, which is a relational database management system, in further detail. Okay, I'll stop sharing.
All right, let me just share my screen. Right. So now that you've heard all about what an object-oriented database is, let's talk about an example of one, which is PostgreSQL. So PostgreSQL is essentially advertised as the world's most advanced open source database management system. And I will be referring to database management system as DBMS. And also I might refer to PostgreSQL as Postgres. So I just want you to keep that in mind. So PostgreSQL, it's considered an object relational database management system, which essentially combines a relational database management system with an object-oriented database management system. And in addition to being able to handle like extensive and complex amount of different data types, it also handles relational database data types as well. So PostgreSQL has an extensive history. It was originally named Postgres when it was developed by Michael Stonebreaker at the University of California at Berkeley, and this was in 1986. But it was a follow-up of Ingress DBMS, which was originally just a relational database project. And prior to being called PostgreSQL, it was also called Postgres 95. But after the team that was working on the project implemented SQL compatibility, the name was later changed to PostgreSQL. As long as they understood that Postgres 95 would not stick with the test of time, so they changed it to PostgreSQL. And so now we'll talk about the features of PostgreSQL. One of the main features of PostgreSQL is its ACID compliancy. And so this ACID compliancy allows for there to be data integrity despite any system abnormalities that might occur within the database. And another one of the biggest features for PostgreSQL is the advanced data types. I mentioned this before, being that it's an object-oriented database. It offers an extensive amount of compatibility to a very large number of data types. So some examples of those data types are things like JSON, text data, images, video, audio, geospatial, and I'll get into what geospatial is more later because I know some people might not understand that term specifically. And this is super important in a world where our technology is always evolving, right? And so companies are trying to capture more data beyond just text, so they're trying to capture everything about their customers. And so this makes PostgreSQL very attractive to those companies. And extensibility is another one of the features of PostgreSQL, which essentially just means that PostgreSQL is amazing in that it allows that new database functionality be added without messing with the original project itself or with the original product. And another one of its features are database size, and that PostgreSQL can handle a large database size. It has no maximum limit, and so it's attractive to those who are looking to, hold data that's extensively large. And I mentioned this before, but PostgreSQL is an open source database. And being that it's an open source database, it has a large community. Therefore, this community has developed a good collection of tools and plugins that add to its functionality, and therefore adding to the capabilities the users has when they're using PostgreSQL. Now, we'll talk a little bit about the applications PostgreSQL can be used in. So it's currently one of the biggest DBMS out there. It's number 2 right after MySQL. And that's a lot of it is thanks to its open source nature and its flexibility in the data types, because it's able to handle the data types that it's able to handle as an object relational database. Just like I mentioned before, it handles JSON, text, images, video, geospatial data. And these sorts of data are used in are used widely in many different fields. So PostgreSQL is a very popular choice when it comes to web applications. It works well with other open source HTML scripting languages like PHP. And it can be used to easily store backend data exceptionally because its ability to store many different data types. And also, PostgreSQL can be used in geospatial applications. And geospatial applications, for those who don't know, is essentially data that captures objects that are associated with a location, right? So maybe someone walks to a park, and you want to capture that data and say this person is age 32, and the park is located here. That is a form of geospatial data. And so PostgreSQL has the team behind PostgreSQL also developed something called PostGIS that runs alongside PostgreSQL, which enables PostgreSQL to handle geospatial data very efficiently. And so that's another reason why it's a good option for geospatial application. And one of the other ones is biomedical and scientific fields. PostgreSQL's ability to run advanced data analytics and its ability to run complex queries is why it's so widely used in a biomedical and scientific field. And some of the notable companies that a lot of people have heard of that use PostgreSQL are Apple. Apple has switched over to using PostgreSQL for a lot of its data. Most notably, they use it for company databases. IMDb, which houses information about almost all movies, I'm pretty sure. And this is where PostgreSQL is where IMDb houses is what IMDb uses to house their data. Instagram as well, like I mentioned before, Postgre is very good at handling backend data, and so Instagram uses its PostgreSQL as a platform to handle their application backend data. And NASA was one of the bigger ones as well that uses PostgreSQL, and they just use PostgreSQL basically everywhere to store data. And then the last one was Skype, where Skype uses PostgreSQL to store chat and call logs. Now we'll talk about the conferences that you can find out more information about PostgreSQL. A lot of the conferences that are big for the PostgreSQL community are ran by PostgreSQL. And so one of them is the PostgreSQL conference. That's literally the name. And it's a conference organized by PostgreSQL, like I mentioned. It occurs annually with a lot of developers, users, and contributors all invited. This is one, I'm pretty sure it's the biggest gathering revolving around PostgreSQL. And the other one is ACM Sigmod. And this is another big conference for PostgreSQL. However, Sigmod is a conference for basically a lot of different databases. But what's important to mention here is that when PostgreSQL was first being developed, ACM Sigmod was one of the first conferences that it was first shown in. And then the last one is PGCon, which is much like PostgreSQL, and it's annual. It's also for users and developers, but it's more of a space where users and developers meet to discuss and build relationships about the work they're doing using PostgreSQL. And so now it's time to have fun. Let's build like a sample database in PostgreSQL. So let's say we want to build a database where about American states, their capital cities, population, average temperature, and size, right? So the first line of, once you enter your PostgreSQL, your SQL shell, you want to first create a table, right? So we're going to create a table and we're going to name it states. Now, this is the code you enter into PostgreSQL. So you go with the title of the first column, and then you go with either varchar, char, integer, or varchar and char are basically strings, and integers are numbers. And so you put the name of your row, and then followed by what form is the data going to be collected in. And so we're going to create the table of states. And so if I go over here in this first picture, you'll see that I created the table, and I populated it with the name, capital, population, average temperature, and size. And now we will now populate our newly created table by using this code. And so we're using the insert into code, and we're going to insert into states. You list out your rows where you want to insert that data, and then you add in the values into a separate thing. And so we wanted to enter New York for the state name. We wanted to enter Albany for the capital. We wanted to enter 8,468,000 for the population. The average temp, we wanted to enter 62. And the size in square miles, we wanted to enter 302.6 square miles. And so if you see here in the second picture, I populated my chart. I populated my table. And here you see that I populated it with more than New York. I also populated California and Texas. You can use the same structure to basically populate, the structure and code to populate as many different states as you want. And then now it's time for let's perform queries on our table. we will check to see all the information we've added. So you want to select all from states. The asterisk basically stands for all. And so when you do that, it should show you all the information or all the data in that table. And now say we want to write a query to figure out how many people live per square mile in every state. So we're going to select name because that's what we want out of it. And we're going to divide the population by size, right? And it's going to be named density. And we're doing that operation from the table states. And here, if we go here, you can see I've put in the code, select name, population divided by size as density from states. And you'll see here, and then it provides the density, and then it provides the name, that's population density. And then our last code, which is, now say we wanted to see what state had a population of less than 8 million and an average temperature of more than 65. So let's say you want to go into a very least populated state, but you want it to be a hot state, and you wanted to pull that information out of your table. So you're writing this code, which is select all from states where the population is less than 8 million and the average temperature is more than 65 degrees. And again, it pulls that information out. The state, there's only one entry that fits both of those criteria, which is Texas. And you can see that it pulls it out here. Okay. And those are our references. And so, as you can see, object-oriented databases and PostgreSQL, as an example of one, are very instrumental tools in our rapidly growing world. They are the backbones to many companies' ability to run smooth and efficient operations. And yeah, that concludes our presentation on object-oriented databases and PostgreSQL. If you are interested in more information, the references in our presentation, as long as the conferences, provide a great amount of information. Thank you.